How might an advanced technological civilization behave, and how might they colonize cosmic frontiers? Economist Robin Hanson has developed intriguing answers to this question in his paper, Burning the Cosmic Commons. In the abstract it says, attempts to model interstellar colonization may seem hopelessly compromised by uncertainties regarding the technologies and preferences of advanced civilizations. If light speeds limit travel speeds, however, then a selection effect may eventually determine frontier behavior. Okay, that's important. Making this weak assumption about colonization technology, we use this selection effect to predict colonists' behavior, including which oases they colonize, how long they stay there, how many seeds they then launch, how fast and far these seeds may fly, and how behavior changes with increasing congestion. This colonization model explains several astrophysical puzzles, predicting lone oases like ours amid large quiet regions with vast unused resources. So this last sentence hints at the Fermi paradox. Why we haven't seen evidence of aliens so far. Another paper by Robin, wrote months later than this one, also in 1998, was The Great Filter, which similarly also puts forward another selection effect that might explain the Fermi paradox, although one far more dire, arguably. We've done an interview on The Great Filter as well, so go check that out after you watch this one, of course. So onward to the interview. Enjoy. Okay, so welcome again, Robin Hanson.
It's been a while, been a couple of years.
Yeah, it has. Yeah.
But we've done like, what, 6 of these so far now?
Yeah, that's right. We've covered topics all the way from the Fermi paradox to the Fermi debate, and
yeah, we did one on the Oxford grounds in the middle of winter, and I was all bundled up.
Yeah, that's right. Yes, that was the 2012. Yeah, it's been fun. Yeah. We unfortunately recently we've had 2 luminaries. Freeman Dyson and Nikolai Kardashev have passed away in the last few months. So I thought it was a good time to cover the topic of galactic megastructures, expansionist efforts, and
it's always a good time to cover galactic megastructures. That never goes out of fashion, does it?
Yeah.
Of course not.
Well, I hope it's it may not. Like maybe it's going to be the biggest fashion in our forward light cone. Let's really hope that it is. So,
right.
While there's been a fair amount of engineering research and all that on, maybe like what would it look like if there were alien civilizations out there, the costs of interstellar travel, and everything, but not much has been sort of covering the behavior. We haven't really done much about theorizing alien civilization behavior. So this is really the purpose of the interview here. So, I mean, why should we focus on theorizing about alien civilizations' behavior? How is it important to take a more sophisticated approach to, projecting ETI behavior in general?
Well, an advanced civilization can do a wide range of things. So if you want to be able to guess what they would look like, how you would see signatures of them, then you need to narrow that vast range of things down a bit, if you can. And if you can predict what they will do with all that capacity, then that will give you a much more specific prediction about what you should look for. And so a key question is, can you? Now, many people who have more of a hard science training, they don't know much social science, and from their point of view, there is no way to constrain that. How could you possibly? Because in their mind, there is no social science.
Yeah, right.
But the more you believe that we do know things about social science and even about biology and more general what competing creatures might do, the more you think we could make such predictions, and of course, then we should. I mean, not only should we make these predictions in order to figure out what to look for if we can find them, but of course to predict what our future will be like. And if we ever meet them, what they'll be like and what we'll be like together. I mean, those are all pretty big, important questions.
Game theory seems to be pretty interesting. I spoke about this a bit with Stuart Armstrong. I was having a discussion on Reddit and somebody said, but what about all these unknowns that we can't really think about because aliens would think so far different from us? How would you respond to somebody saying, how would you know the mind of God? in this case, I think they're really referring to advanced alien technology or advanced alien technological civilizations.
I mean, again, the key question is, do we know anything besides physics? Do we know anything about organisms and organism behavior and social behavior? On our planet today, there are many species, and many of them are social, and we can understand a lot about social species behavior all across the planet, not just human behavior. And even humans, we can understand human behavior not just in our place and time. We can understand human behavior in other places around the world and in the distant past. So that suggests we have theories that are not specific to you and me and our friends. Of course, there's a question of how general they are, but that's also a question about physics. I mean, our physics theories look general, but of course we could learn that they are only physics that applies in a particular part of space-time, and other parts of space-time have completely different physics. But we might as well take the physics we know and see how far we can go with it, and we might as well take the social science and biological science we know and see how far we can go with it.
From my understanding, it doesn't look like, according to what most astrophysicists have said, that space is all that different elsewhere, at least in the observable universe. I mean, the laws of physics.
Yes, but of course, beyond the observable universe, we can't constrain it as much, and so it could well be the space, that the universe is spatially infinite, that it just keeps going on, in which case we can only see the tiniest fraction of all of that. And within this universe where we can see the physics, then the question is, how much of social science can we see? And so the more that we understand social science and biological science in terms of the physics, then the more confident we could be that we've got a handle on it.
I mean, a lot of people have used intuitive social theorizing to sort of make sense of what an alien civilization how they might behave. But it brings to bear, like, what kinds of approaches can we take to, I guess, more accurately or attempt more accurate predictions about how they might behave.
Well, I will take this opportunity to mention my first book, The Age of M. And
yes,
in this book, I
also
take a certain approach to predicting future social behavior, and that's the same approach we're going to take here to think about the larger cosmos behavior, which is to say, when creatures are rich and comfortable and don't face many threats or constraints on their behavior in terms of wealth or resources, then it is much harder to predict what they will do. You will have to know in detail what they want in order to figure out what they do. But when creatures are near the edge of feasibility, when they are starving, say, or very poor, in a strong competitive situation, then we can predict more what they will do because we know they are basically doing what competition requires. And so my book, The Age of M, basically analyzes future robots, brain emulation kind of robots, in a world where they can reproduce so easily and quickly that they're in a Malthusian world, and so they are near subsistence levels, and so I can predict that they will mostly be doing what it takes to survive at subsistence level, i.e. producing and working hard to make the things that they need to survive. And that's true for our ancestors thousands of years ago. Subsistence farmers are similar the world around. Maybe you don't know what they do at their annual festival, but you could know what they do most of the year and most of the day because that's what they have to do to survive. We can understand a lot of the behavior of human subsistence farmers. And of course, most animals, we understand their behavior because most animals are also in a subsistence world, in a competitive world where they basically need to do what they need to do to survive. So our attempt now to analyze the future, we can say, well, if we can find a context where we would see them being very competitive, where small competitive advantages would make small subsets of them win out compared to others and expand and dominate behavior, then we can understand future agents' behaviors or alien agents' behaviors as long as we can understand what sort of competitive situation they're in.
Mm-hmm. Right, and you wrote a paper called Burning the Cosmic Commons. Now, this was written before the Great Filter paper, just a few months before, by the way. Were you going through a big sort of where all the aliens sort of phase back then?
At the meta level, I was not focusing mainly on what it takes to get tenure. I was allowing myself a range of freedom to study a range of things that I thought were interesting and important, and I was neglecting my career. So within a few years later, I knuckled down and focused more on my career, which is why I stopped doing work like that. But that sort of work is more naturally the kind of thing I want to do if I'm just studying what I think is interesting and important.
Oh, you stopped having fun? Oh, and
Well,
focused on tenure.
and I managed to squeak by, luckily.
Now
So
you
it
have
was- it
tenure,
was-
so...
I do have tenure, so now
So
I
now
have
you
more
can go
freedom
back
to
to have
study
fun.
what I want.
Okay, so, well, I mean, what was going through your mind at the time? What was the motivation? Other than it being just fun, why was it a subject of interest for you?
Well, I think it's easy and obvious to explain why it's an interesting subject. What might be hard to explain is why I thought I could make progress. So I was basically becoming better and more tooled in the sense of acquiring more and more intellectual tools. And I was looking at these questions that everybody thinks is interesting. And I was being brave and arrogant to say, I think I could work on that. And just jumping in and doing it. In a way that most people don't. Most people don't, both because it seems arrogant and impossible, and also because their career incentives push them elsewhere. And so I just jumped in and tried to do these things. And I thought I made substantial progress. But of course, that's not too surprising, knowing that hardly anybody else is trying. So of course, the interesting question is, what would aliens be like? And what signatures might they leave in the world around us? And I realized that at least a certain set of assumptions would let me say something about that.
You think it's still the case? I mean, this was written 2 decades and 2 years ago, 22 years ago, right?
Well, I certainly don't think these results have been superseded by any. We haven't learned anything to supersede these results, but we can talk about how questionable the assumptions are. So certainly other people have built on different assumptions. So let's go into it. Let's talk about the key assumptions here.
Okay.
So the scenario here is an expanding colonization wave. And we're focusing on some agents near the frontier of that wave. So now right there, that's not obvious that that's the way it plays out.
Sure.
Some people have imagined that when a civilization gets advanced enough, that it can, from just one planet or one solar system, create enough colonization ships that you could send one ship to every star in the universe, right from that first place, in which case there's one colonization act, the one time that the initial star system sends a probe to everywhere, It
So,
just has
we're
to
talking
make...
about probes and not massive, ships.
Right.
Like,
So if it could
the size of
send
something.
one to everywhere at the speed, it could make 10 to the 40 of them, and they can each go at near the speed of light directly toward each star in the universe. Then colonization is this one act by one central actor who just colonizes everything all at once. Boom. So I'm not assuming that.
Infinity in 6 hours, paper by Anders and Stuart Armstrong.
Right. So my assumption for this analysis is that colonization's harder than that.
Yes.
You can't make enough probes in one star system to send one to each star out there and be done with it. You can't for many potential reasons. One is that probes are expensive, say, and one star system can't make 10 to the 40 of them. Another can be that probes are not reliable. That is, as they go between the stars off into the universe, things go wrong.
Yeah.
They can't go for a billion light years, repairing themselves and maintaining themselves and avoiding obstacles and finally getting to their destination and then reliably setting up shop and colonizing the star and everything around it. That's a pretty ambitious technological requirement for these probes, that they be small and cheap and very reliable and very fast. So my alternative assumption was, no, they don't go very far. They fall apart, they break, and you can only make so many of them. And so you have to have a wave of colonization. You have to, from a particular oasis, we'll call it, we can generalize it to say maybe they're not stars, maybe they're something else. From an oasis, you send out seeds, to generalize the probe. Seeds go from an oasis, and they land on other oases, and that you have to do that over and over again to get all the way to the other end. So like life on Earth with, say, flowers or other plants, they spread across the landscape, not in one vast bloom where one flower makes enough seeds to, spread across the entire planet. Instead, flowers colonize land by one flower making many seeds that spread maybe over a few miles, and then those growing up to make new plants that then spread out over a few miles further, etc. Or we can take the even more similar example of coconuts. These are seeds of palm trees, which live on islands in the ocean, and the coconuts fall from the palm trees and float on the water off to another island where they could make another palm tree. And again, my assumption is more like what we've seen with biology, that a biological species over time is many generations of making many seeds, having the seeds, some of them survive and grow up and produce more seeds. And so that's my key assumption here first, is that colonization waves through the universe is this repeated seed process. And furthermore, I'm going to say the distance that a seed goes on average before it lands somewhere and grows up is going to be small compared to the distance from the origin to that place. So we imagine, something's 1,000 light years from the origin of this colonization wave, but it only goes 1 or 10 light years until it lands somewhere and grows up again. So that's
this
one
is
assumption.
this is more like the like colonizing a galaxy and not like
Right.
spreading out from galaxies to galaxies.
Well, even from galaxy to galaxy, again, the key idea is, you've already gone 20 galaxies from your origin. And if you go to the next galaxy, that's only 1/20th of the distance from your origin. So we're near a relatively flat colonization wave. We're far away from the origin. And another assumption that I make, for more mathematical convenience, is that these oases are spaced by some distance, say, a light year for stars, and that the typical distance a seed goes is, more than one of those. Maybe, 5 or 10 or 20. So that, because of that, I can then use differential equations to model smooth functions that talk about how far the seeds go and the density of oases. And so most of my analysis was a mathematical analysis, basically, given that assumption that, the spacing between the oases is small compared to the other changes. So, you could do a simulation if that weren't true and probably get similar results, but I found it convenient to do this differential equation analysis.
Sure.
And
But just quickly, for those who don't have a clear picture of what burning the cosmic commons is, do you want to just give like a very simple, intuitive explanation of this expansion behavior, like how it starts and where it goes?
So I mean, the key thing is we're well into it. We're long past the origin. So, if you and I grew up in this world and this was our life, we might hear stories of long, long ago when this thing started, but that's ancient history and it's not very relevant for our lives. What we do is, we may be on a particular planet or a particular star, some oases, and we've been growing there for a while. A seed landed there not too long ago. That was a successful rare event. Yay, us. Yay, our seed. It's been growing as fast as it can here. And we are anticipating the moment soon where we are all going to leave. We have been building these resources and building these factories and mines. And now we're ready to turn all those resources toward constructing seeds and launching them. And now, we're about ready and we have all these seeds we've made and we've just launched them all. We are throwing all our resources into this launch. And after this launch, we really won't have anything left here. There'll be some equipment that's sitting around, near the end of its useful life, but nobody will be left here because we all want to go farther. And so at this moment, maybe 1 million seeds go flying off. And now we all fly off in the same direction because this expanding colonization wave is all moving in a particular direction. If we went any other direction, when we landed somewhere, it would already be taken. All the oases around us are all taken. And the only way we can go find a new oasis is to go pretty far away from where we are and to head exactly in the direction away from where everybody else already is, in the same direction everybody else is heading. In addition, we look at the stars and we pick out a place we're going. And each seed has a plan of where it's going to go. And each seed is going to try to get there. And when it lands there, it's going to plan to grow. Now, Along the way, most seeds will die. They will suffer some sort of catastrophe. That's true for pollen today. Most plant seeds, a plant can send out 1,000 or 1,000,000 seeds, but on average, only one of them grows up to make a new plant to produce more growth. And so that's what life is like for these seeds. So me, you and your million friends, we're all in our own little seed, and we each fly out, and only one of us is going to make it, and the rest are going to die. So it's a pretty gruesome, harsh world. But one of them, we hope, will make it. So along the way,
we send copies of everybody in one time.
Well, it could be 1,000,000 copies of you. So, but still, only one of you is going to make it. Maybe you can, but still, for each seed, has 1 in a million chance of making it. And so, the seed could just break apart by itself. It could have internal failures. It could hit something along the way. It could, be unsure about and be, knocked off by something it didn't anticipate. And then when it gets there, it might already be taken. There's all these other places out there sending seeds too. And we haven't all coordinated necessarily on who gets what. And of course, if we arrive at exactly the same moment, we could fight over it. But most likely, one of us got there first and has grown to be bigger and just squashes whoever comes second. But that's part of what you have to do. As soon as you land, you set up defensive abilities. And you watch for other people trying to grab your place, and you try to make sure that they can't, because you're there first and you have a better shot. And then the game repeats. And we just keep going on and on and on and on in this game. Now, in this game, we have a lot of strategic choices to make. We have choices which oases to land at, which are the most attractive ones. How hard do we make our seeds? Are they tough so they can withstand a lot of stuff? Are they fragile and cheap and we just send more of them? How fast do they go? How do we grow when we're at any one place? What are the resources we use to grow, and what sort of infrastructure we make in what order? We have all these choices to make. And the key idea here is that this is a competitive world. And so these choices are constrained to be whatever works best.
Right.
And at the frontier, there's just a certain average speed by which descendants continue. They land somewhere, they grow there, then they move at a speed, and then they land somewhere and they grow there, and that produces an average speed. And that average speed is the fastest feasible speed. If you could find some other strategy that you could move a little faster, then you would be out in front of everybody, and then by the time they got there, it would already be taken. So the only way...
You'd be getting the competitive advantage then, right? And then that would become
everybody's looking for that competitive advantage. Yeah. And so we can figure out what this behavior looks like at the frontier. I can use mathematics to calculate it if we knew these various functions. And I can also calculate, well, what happens if you fall a little behind the leading edge? So when you're right at the leading edge, you know that if you go out there and pick something, no one will be there when you get there because you're right at the front. But as you fall a little behind, and there's some people out a little farther than you, then you know that now they will get somewhere before you do. And so now you have to worry more about that. And so I can calculate how your behavior changes as you fall behind. And so what happens is you tend to stay at any one place longer, so you can build up more seeds, and then you go out a little slower, and I can calculate those sort of changes. But there's a minimum speed you go at, no matter how far you fall behind. So the prediction here is that a wave of colonization, when you're looking at the winners, when you're looking at the many generations after winners who continue to do the winning strategy, these creatures are obsessed with continuing to win. They are trying desperately to get as far out in front as they can and find the best places and grow there as quickly as they can and defend themselves from somebody who might want to grab it, and then shoot out in the best way they can with the proper hardness and cost of the right seeds at the right speed at the right destination, so they can already make it. So this model here makes predictions about these agents' behaviors, and this could be our future. It also could be aliens. That is, if aliens were ever in a competition where they started in some place initially and then spread out, and at that frontier they were still competing with each other, well, then this is what their behavior might look like. And so then we might ask, what does this predict? How would this show up visibly if we looked at the universe where a wave had been passing through like this? And therefore, how could we see if they had ever done this and where they are?
Sure. But before we move on to any residual evidence of colonization waves, let's talk about the types of resources that the initial wave would
Sure.
try and burn. I mean, the quick burning resources and
Right, so
the
they're
slow burning
optimizing
resources.
for the speed, right? So if we presume that, what varies is the oases, but not the space in between them, then that's the main choice they have. What kind of oases stand it? So they're going to land somewhere and build a seed, and then they want it to go fast. So they want to have a resources where the materials they have available to them can make a good seed. They're sufficient to make a seed. If there's some kind of metals or something that were more appropriate, then they'd want those. And then they want some sort of fuel, of course, to shoot along, to fly off to the next oasis. So they will want to find or make that sort of fuel that would let them move. If they use fuel, unless they're just launched initially and thrown and fly, coast the whole way. And wherever they land, they will just want resources that they can grow really fast from whatever seed lands there. So the seed will bring whatever it thinks it needs to bring in order that the oases won't have. If there's something you got to have and an oasis might not have it, then you better bring it with you. But you'd rather make a smaller seed and have more of them and then build whatever you need when you get there. And so you want to have resources you can build really fast with. So obviously one prediction is it's going to be dense. If you've got resources spread across an asteroid field, well, now it's going to take you a while to go around the asteroid field and all collect them together. And that'll take longer. So all else equal, you'd want something dense, all collected, all together in one spot. So if it turns out that, I don't know, quark stars are a better resource for growing, then they'd be looking for the quark stars. Or, there's a lot of exotic physics, materials or particles, etc., that, we don't know if they're out there in much quantity. But if they are, then those might be the things aliens would be looking for. But of course,
Right.
if it's not some exotic material, if it's not exotic material, they'd probably be looking for something like a black hole or a white dwarf
Yes.
or something dense and full of energy and material that they could just immediately start building from. But of course, if they're not willing to do nucleosynthesis, then they might want some heavy elements like, carbon and iron and things like that, rather than going to a white dwarf that only has hydrogen and trying to turn it into all the other elements. That might be more trouble for them. They'd have to bring along something that would let them do that. But so the key thing is whatever these resources. So we don't at the moment know exactly what would be the fastest growing resources, but we can be pretty sure they'd be dense. And eventually, as we understand the universe better, we'll have a better idea of what would be the fastest growing resources.
Now, you mentioned about leaving weapons behind or defending their position. Often, it comes up what kind of psychology would an alien civilization have to want to just take everything? Isn't that really greedy? If there was an ethical civilization, would they want to do that? Why would an ethical civilization want to take up as much of the universe as possible? And how would you distinguish between an unethical compared to an ethical civilization?
Well, our standard theory for why ethics exists is that social communities, organisms, have coordination problems.
Yes.
And ethics helps them manage their coordination problems. So then we can think about coordination problems in this context and think about how they would overcome those coordination problems. But our theory that ethics is there to overcome coordination problems doesn't predict that they will do something different than what's in their collective interest. It still predicts they will do that. So, humans have been pretty rapacious for a long time, and we have pretty much grabbed all the animal and mineral resources on the planet that seemed useful to us, and we're mostly in that mode now. When we use these resources locally in such a ways that hurt others of us, well, then ethics comes to bear, and we might say, don't pollute because your air pollution is entering my lungs and making me sick. And that's the point at which most ethics applies to human behavior, is when humans hurt other humans. But humans are not very inclined to sacrifice their own rewards for non-humans. But even if they are, the point is, this is a theory of sort of the optimized behavior, the selective for behavior. It still allows for variance and variation. So
Sure.
we are today the winners in this biological contest on the Earth, but we're not obviously the most optimized behavior. In fact, I have this essay called "This is the Dream Time" from a while ago, and that idea that we today are not doing optimal competitive behavior because we're rich and comfortable. And that's how we could predict how the future will be different from today, is just by predicting that over time that will be selected against. When we do things today that are lose at a competition, then those people who do those things will in the future, there'll be less of them because they're losing. So
that's unfortunate.
If these aliens have different varying behaviors, some of them may be more ethical or differently ethical. For some of them, that more ethical will help them win because they'll be more cooperative in their contest. For others of them, that more ethical behavior may have them lose in the contest, and in which case that behavior will be selected against, and then generation after generation it would be repressed. But that's the same thing you should predict about us if we continue in competition. That is, if humans today continue to compete, and some of us are ethical in ways that aren't rewarded in the competition, then we predict that sort of ethics will fade away. Of course, that brings up this issue of coordination problems. And we can think about coordination problems in our world today as well as in this future world. So you could say, well, if enough of us coordinate, maybe we could promote ethics that we like, even if it would lose out in a competition. And we could also think about how that may play out in this future world of the cosmic commons competition.
Well, I've interviewed a couple of people, and on this, and or a couple of who was it? Stuart Armstrong recently, and Luke Kemp in the past, they brought up. They thought that for an alien civilization to remain cohesive, they'd have to have solved coordination problems, which equates to ethics to a degree, and therefore it still makes sense, at least according to Stuart, to take up as much of the resources and positioning as possible, so that ethics wins against the bad guys.
Well, so let's walk through that in this context. I mean, we can make some discussion just at this abstract level of ethics, but we get a lot more leverage if we can get something concrete to focus on. So, in this cosmic commons context, blah, 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 there's the question of whether you can enforce cooperative agreements. So the problem is, at the edge of this frontier, if I go nanny, I'm going to do what I want. The question is, what can you do to me? Because I'm going as fast as anyone can go. So in some sense, you can't, tell the police come get me and arrest me because they can't catch me. Now,
yes,
what you might be able to do is...
That's a big difference between the universe, the eternity in 6 hours model.
Right, exactly. So part of the issue of this expanding wave is that if people are going as fast as they can, you can't catch them. Now, what you might be able to do is to shoot a weapon at them. So there's no theorem that says you couldn't have a weapon whose projectile went faster than this wave.
Like light.
For example, a laser or a high-energy weapon. And so, in principle, you could enforce an agreement by threatening to shoot them, even if you can't get to them, to shoot them if they misbehave. But the problem is, you can't target this weapon unless you know where they are. So the more freedom and discretion they have to vary their trajectory and to vary their destination in ways that you can't anticipate, well, then it gets hard for you to enforce your threats via threatening to shoot them.
I guess you could try and target positions in which you think that they might track, like waypoints in the future trajectory.
You might,
escape.
or you might just try to destroy all the stars in their path.
Exactly.
But of course,
yeah.
But now you're destroying all the things you might want to use and when you got out there. So it's, pretty severe threat you're trying to impose. So it might not be obvious you'd actually be willing to do that. Destroy all the universe out there just so they can't have it, even if you can't have it as well. Now, there is a more interesting scope for agreement. If you imagine little, cones that cooperate together. So you imagine a whole, say area of the surface, and those people on that area try to cooperate together. Well, one of the things they can do is to agree on who gets to go where, and now they can avoid the inefficiency of two origins showing up at the same place and fighting over it. So there'd be some efficiency that way. So a group near the surface that cooperated in that degree would be able to move out farther faster because it would be avoiding the cost of this conflict. But that group doesn't necessarily, have to obey what everybody else wants them to do. It would be a local, small-scale cooperation, not necessarily a global cooperation. Of course, even within one of these oases, there's going to be coordination, right? So presume that when a seed lands somewhere, then it grows, that place coordinates. If within that place they fight a lot, then that'll slow down their ability to grow. And therefore there'd be, an incentive to cooperate in how you manage an oasis before you send things out. And then all the seeds that go from that oasis, at least they wouldn't all target the same place. They could each target a different location. It would be seeds that came from another oasis that you might be in conflict with because you hadn't coordinated with them. But then over a larger area, you could coordinate for targets, but that still wouldn't be the same as sort of a global coordination of all of civilization or, the entire set of everything that started from the same place.
Yeah, indeed. Right. So, what do you think is what's your favourite strategy for expanding? What do you think is the most likely type of civilization that will be on the frontier? What kinds of social structures, configurations are...
So this is a relatively local sort of world. In this world, you don't require very global coordination. So it's not like our world economy where we have, big economy, where we specialize in different things and ship things all across the world to other people and get all these gains from specialization. This world really can't support that. Each oasis is all by itself, basically. Now, they could coordinate by, say, sending each other, bit streams that represent new designs. So if there's innovation in this world, they could produce and share via innovation. But most plausibly, innovation is a thing that happens for a certain period in our history and then ends, and this could well be after that period. That's a surprising thing for many people to hear, but it just seems like the universe is large enough and physics is limited enough that eventually you would just figure out all the best designs for things, and innovation in physical devices and mining and energy sources and things like that would just run out, and then there would be much less scope for these people to trade designs as something cooperation. So that would be another way you could threaten to, punish somebody who's not cooperative because they were just going to shut off all the new designs. You're not going to get them. And then your descendants will be at a disadvantage to ours because we'll be sharing these designs and you won't. But if you don't have new designs to share, then that's not such a credible threat. Now, to me, it's more interesting to wonder, well, say a colonization wave passed, that's not the entire history of the universe. What happens next? Colonization waves would spread out, and then if there were other waves, they would eventually hit each other. The surfaces would smack into each other. And now there would be this residual of everything that was behind the colonization wave. And now we might ask ourselves the question, what can we predict about their behavior? Because in some sense, that's the more likely thing to see out there. If there were many colonizations waves that happened a long time ago, then they would have whizzed by and been long gone and eventually hit other ones. And what would we see next? So the interesting thing here is
I don't think you went into this in your paper.
Not very much. So I had another essay called The Hard Scrapple Frontier.
Yeah.
If you recall, and I talked about it a little bit there. But the key idea here is that this new behavior of people who stay somewhere after the wave is passed, that behavior is mostly the random residual of failures in the first game. Right? So there's this first colonization game where everybody's really trying to get at that edge and they're really winning out to be on the edge. And then some of them lose that game and slowly fall behind. But even then, the optimal behavior is to just keep going as best you can. But some of those will just fail to do that and have some sort of random variation where they just do something they're not supposed to do. And not what they were designed to do and not the thing that wins the contest. But that happens in the world. Not everybody does everything exactly, the most efficiently that would help them win competitive contests. Sometimes people do stupid, counterproductive things. But here the prediction is that this entire future after that is all resulting from those stupid, counterproductive things. It's all of those people behind the wave who figure that out. Now, when two waves are coming close to each other and they start to see each other, now at that point you would predict that they don't just go crazy to get to the edge of the wave. Now they realize, well, I guess it's time to slow down and grab the stuff and do something here. And so near where the waves intersect, you would expect then to see more deliberate behavior that's predicted by some theory like this. But well before that, when you have seen no indication there's another wave out there to intersect and you're still racing, all that world is full of the rejects, the failures, the ones who screwed up.
Right. So I mean, they could have a lot more time to burn the slow-burning resources and
Right.
hunker down. And
Now, so one key
become
parameter about that
defensive.
is the relative cost of offense and defense. So one perhaps plausible assumption is that defense is cheap compared to offense. So say I've got one star system and you've got another star system nearby. The cost to you to launch an attack from this other star system and bring it over here to try to grab some of my resources is much higher than the cost to me to just set up defenses right here. And if that's true, then you could have a lock-in effect. Whoever grabs a star can kind of do whatever they want with it, as long as they pay a certain minimal amount to defend it. And then you could say, well, we can't predict exactly what they do because they're kind of random rejects, remember? Random rejects and failures who fell behind the front lines who just happened to say, all right, to hell with it, I'm just going to stay here and do what I can with this thing because I've clearly failed that win. Then they could just have a wide range of strategies and preferences that would be hard to predict or constrain because, again, they're random. They would be maybe some variation on that optimal strategy. So what if we can have a model of how variations are produced in this world, then we could say, well, they will pick from that space of variations and that might help us predict what they would do. But we'd need a theory of variations, basically, a theory of failures, of what kinds of strategies that they would tend to pick if they didn't pick the exact optimal one.
I'd be interested to know what your thoughts are on the distribution between successes and failures. How much space would be taken up by failures compared to the people in the front line?
Well, so in our biological world of animals on Earth, of course, many animals fail, but then they die and get eaten, and they don't have much of a legacy. But of course, most species are dead that ever were on the planet. And most, even males at least in most species, never give any descendants. So, our world is full of failures, but they go away. But in this scenario, you see, the failures fill the universe. And so we have to understand and see what those failures would be like to see what this universe is like.
Well, I mean, what would you expect a failure civilization to look like? I mean, would you be able to detect a difference? Would we be able to?
Well, so by definition, they are some creature or organization that had a certain set of preferences which were oriented toward winning that contest, and then something random happened to distract them from that contest. And that's the thing that's hard to predict because you don't really know how those preferences were encoded exactly. So
Video
you don't know
games.
exactly, what would be a small variation on it, right? Maybe they would mostly want to play video games of the contest and keep pretending they're in the contest, but stay home and pretend. That would be one story. Or another thing is they somehow orient their time axis to think, well, I'm going to keep the contest going here and sort of map the spatial contest onto what they do locally in time. I don't know. But that's the hard thing to predict.
Mm-hmm.
But it does suggest there could be a wide range of what we call slack or ability to have some freedom. Again, if defense is much easier than offense. Now, that could be false in the sense that, if it was possible to make a weapon that just shot something at a star and blew the star up, then in some sense offense would be cheaper than defense. And now we predict they'd all blow each other up. And there's not much left because, they can.
That's another sense of burning the cosmic commons.
Right. If you just have a bunch of random people with random preferences for whom attack is much easier than defense.
Ouch.
Maybe they'll be, then there's the question of how well can they maintain internal discipline? That's a related parameter. If it's hard to maintain internal discipline, then it'll just fragment and keep fighting. So maybe that brings us to the question of coordination when you are stable in one place, rather than coordination in this wave. So we've said that at the frontier, if speed of light is a limitation on information and motion, then it's really hard to discipline the frontier, You can't chase them down and you can't even really shoot at them. And so they can do what they want. But when you're nearby each other, now there is more prospect for cooperation and coordination because now you can punish them for deviations. You can get to them. But still there's this open question, how much coordination and cooperation should we expect? So this is obviously a very fundamental question. And I mean, a lot of people in sort of the world that we share, they like the scenario where obviously we don't coordinate much right now. We have limited coordination. We don't have a world government, for example. And then they like to imagine that our abilities to coordinate will rapidly and dramatically increase. And then there will soon be this point where we basically coordinate about everything. And then from then on in the universe, it's all cooperation and coordination. That competition is over and conflict is over because cooperation will just win. And that's a pleasant image in the sense that, well, cooperation sounds better than conflict. And also makes us really important because if you imagine that soon, then, we will be the ones who determine like what this regime of cooperation is forevermore. And that makes us really important. I'm less optimistic about sort of, total cooperation forever and ever being something we can achieve anytime soon. So I tend to more think cooperation and coordination is valuable and it's something we pay cost to achieve, but it's expensive and hard. And so even today we have limited cooperation, not because we don't see the value of it, but because it's just actually very hard to achieve. When you try to create organizations to cooperate, there are just so many ways that can go wrong. Splits up into factions who then fight each other, or people try to subvert it and, have it pretend to cooperate but really serve their side. It's just hard to make organizations that are reliable and accountable and do what you want them to do. And so theft and predation, I think you kind of have to presume will remain in many ways.
And there would also be this sort of interstellar camouflage, cosmic camouflage, where people are pretending to be nice, but actually,
well, of course, right.
It's just
that's part of the obstacles, right?
Insidious game.
So some people imagine by the way we'll cooperate is we'll be able to see inside everybody and see all their deepest feelings and values. And once we can show each other all our values are kind, then we'll all cooperate. And again, I just think it's going to be very hard to isolate our values in that sort of way, to put them in one spot and make them very visible and clear. So a big creature like you and I, there's no one simple place you can go in our brain to find our values. Our values are spread across the whole thing and in a very complicated mapping. It might be possible, people imagine, to create a creature which has a very small values module that's very transparent and simple, and then a big, massive facts module, which is everything else, and somehow have that facts mess not mess up the values. Not misinterpret or reinterpret or subvert the values. But that seems really hard to me. I mean, certainly that's true in most real organizations today. You can have a mission statement in the company or the nation or whatever, but then who's in charge and who they know and what they talk to, that affects a lot of the actual values expressed. And it's just very hard to make anything where the values are that isolated.
Right.
I was good. So for future cooperation, I wanted to mention before we're out of time here that one of the most interesting things is that if you think about, say, resources to support computation, then in our standard models of reversible computation, the number of compute cycles you can achieve depends on how slowly you run the processors. So if you take twice as long to do each step, then you can do twice as many total steps with the same amount of resources. So that says there'd be this cooperative gain to us all slowing way down and really taking a long, long time to use these resources. Now, the problem is, if any one of us deviates and, say, tries to grab the other person's resources, then the more slowly we've been going, the more resources we've saved up for them to grab. And the more slow we're going, the harder it'll us to notice things and defend ourselves. And so I predict that given some small rate at which people might be able to steal something and grab things, even if they usually can't, that would sort of set the limit on how slow you could go. You would need to go fast enough to watch out for these sorts of illicit grabs. And in some sense, then, the amount of computing we can all do in the distant future depends on how cooperative we can get. And my prediction is we don't get infinitely cooperative. And in fact, our ability to cooperate probably sets the limit on how much we can do. I mean, in principle, there could be other physical limits that set the limit, but I would say cooperation probably sets the limit because it's just hard.
Right.
And so that creates a sad but, familiar story of a great potential limited by the fact that we don't always cooperate and that we fight each other.
Well, it seems pretty important. I mean, what I guess, aspects of decision theory or cooperative theory, if there's such a thing, can we focus on now to determine whether we can...
It's most likely that we don't determine it now.
Yeah, right.
It's most likely that they will just have to work on this later.
Okay, right.
So I mean, when we're playing futurists now, I mean, it's just fun to try to think about the future and anticipate their world and their problems. But for most things we figure out about the future, we're probably not able to do much about it now. Presumably, there might be a small set of things where we have a high leverage now. If only we make the right decisions now, then that will make things go better in the future. And it's maybe well worth looking for them and then trying to do the right things. But, typically that's not going to be the case.
Well,
most things that are happening in the future we can't influence.
A lot of futurists out there.
Well, if you just look in the past, I think if you just had somebody 3,000 years ago or 1,000 years ago and said, the future's coming, what are you going to do to make the future better? It's actually really, really hard to figure out what they could have done. It's very hard, even if knowing the rough overall arc of history, to make a concrete choice 1,000 years ago or 10,000 years ago to make things go better. Obviously, if you knew particular innovations, then you could introduce them to somebody and then they could win in a local contest. But that's not the same as making everything go better. That's helping one side win. Mm-hmm. And so that's how I think that's how you should expect the future to be as well. Like our relation to the future, our best guess of that is, the past relationship to us. What could they have done to help us is probably similar to what we could do to help the future. And so there probably are a few things, maybe if we had saved the Library of Alexandria from being burned down, then, greater things would have happened. But you'd have to know a fair bit to be able to pinpoint and identify those lever points where you could do a lot of good. And that should probably be true for us. Most of the problems of the future will just be things the future has to deal with. But we should be looking for the levers we might have now. And there probably are a few. And whenever we find one, we should definitely do what we can to make use of it.
Mm-hmm. So even if we did see signatures of colonization waves, how would that affect our behavior?
Well, we haven't talked about what the signatures would be yet, actually.
Yes, I know. So, you were going to get to that, so I was going to ask.
So we're almost out of time, so I should at least mention that. So the key thing that goes on is, seeds land in an oasis, they burn up some resource, and then they send out new seeds, most of which crash and burn. So you might be able to see just a wave of colonization out there in the universe, and that would be just a big flat surface where a lot of activity was happening. And that surface would be moving in a particular direction. So we could look very far away to see if we see such surfaces. But if you're far behind that frontier and you're looking far behind, the main thing you should expect to see is missing high growth resources and seed debris. All these seeds were moving in one direction and they all smashed or broke. And their remains would be around, some of them. And we might be able to find the debris of broken, failed seeds. And in addition, we might find missing resources. We might, say, use fundamental physics or stellar evolution models to say, well, we ought to expect so much of this material and so much of that kind of object, and then we might find they're missing. And that would be a clue to say, well, look, a high-growth resource, a certain kind of quark star, for example. Theory predicts quark stars. Theory also predicts quark stars would be a great thing to grow from. And you don't see quark stars, then you go, maybe the aliens took the quark stars. They came around, they burned them up, and they're headed on. And then, of course, whatever you would make with the quark star, you should expect to see the debris of those seeds out there smashed into something else.
Because they don't bother cleaning up after themselves.
Well, of course, right. Exactly. I mean, they're focused on getting as far as fast as they can.
But would they leave weapons behind them so that they'd be able to, knock off people who are trailing behind them?
Well, if they wanted to use a weapon, they might leave it there, but they would only leave it with as much resources as they expected to use, and they wouldn't maintain it past the point at which they used it. So we might well see, debris of weapons, once useful weapons that have now decayed and fallen apart, sitting there. If You expect, but that's a weaker prediction than the seeds. The seed is a robust prediction. Most of the resources goes into making seeds and to shooting them off. And so, of course, seeds might be the seeds themselves and seed launchers. So if there's a way to make a launcher that makes it easier to send seeds out, then they might have built big launchers, and then it might be hard to take apart the launcher and turn them into seeds. Obviously, that would be the last thing they do. And once they have a launcher and they send out seeds, they say, well, can we take apart this launcher and make slower seeds? And, they'd be trying to recover all the resources they can, turning them into seeds as far as possible.
Now, you mentioned that there were, in the paper, there were things you weren't considering at that time. That was the colonists whose preferences differ substantially from the front wave or the front waves. Would you say that they're the failures?
Well, that is what I meant, yes. So that is, this is a selection process that's selecting for a certain behavior at the frontier. Now, that behavior at the frontier can be encoded in many different values. As long as those values in that context all achieve the same behavior, then they can be at that frontier and win. But as they fall behind the frontier, those differing values might induce them to do different things in that new situation. If they finally sort of give up and saying, I can't win this contest, and something random makes them be willing to give up, then all these different ways their values are encoded might produce different behaviors when they stay behind.
What about
that would be the origin of the variety of behavior you would see.
Sure. Now, if we're late to the game, and there's been alien civilizations that have sort of began billions of years way before us that we even had a chance to. If we wanted to catch up, would we have a chance? What could we do?
We couldn't possibly catch up to one of those waves, but those waves would have either gone on forever or they would have hit some other wave, and maybe some reflective behavior coming back from it. So, if you see that your wave is about to hit another wave, now you realize, well, this chasing the wave forever isn't going to work. I'm hitting a limit here. And now you'll ask, well, how can I win the contest I'm now going to see where we both, approach each other at this frontier? And now I think, well, maybe going back a bit might be a little more attractive now, actually. And they'll start to have a second wave moving back away from this, a reflection, basically. And then you could have reflecting waves going back and forth in some sense. But you should expect that you're just way behind. Your best chance is to hope that you will reach the frontier of technology quickly before they see you, at which point you'll be as equal to them. For as long as they're better than you, you're lost.
Yeah. So as you mentioned before, there would be some sort of a point at which we could no longer build better technology. There would be all the discoveries about physics would have been made, and we would reach an asymptote where there was not much progress from there. Yeah.
So we should just mention, one self-consistent theory is that there has not been any wave, and we are the first. It's a surprising account, if you like. On the other hand, if they had been first, then we should expect to see stuff out there that we don't see, perhaps. In which case, the remaining theory is that we're the first. But then this becomes a theory of our future. It says that unless we can find a way to strongly coordinate before we move out and start to expand, it will get much harder to coordinate after that point, and then we will be competing on the frontier to expand as fast as we can, and then our descendants will race out and burn the cosmic commons.
So we want to be the ones to race out and burn the cosmic commons before the others do.
Well, no, we might want our whole set of descendants to coordinate together to find a way not to just have this wasteful contest.
Oh, yes. Oh, good. Yes.
United Nations or solar government or something, we might say, is there a way we can avoid this contest? Because once it starts, you won't be able to avoid it anymore. But maybe we can set up a perimeter and prevent anybody from leaving until they all, agree to the right conditions that we can somehow keep going. That's a pretty
but
tall
enforcing
order
that as the,
yes, that would
the
be
circle
really
of this wall of colonization gets bigger and bigger. You can't just
it would probably be easier just to enforce it with your local political officers, right?
Sure.
Like in the old Soviet Union, every sub had a political officer, right? You have every seed has its political officer. They're ready to enforce the rules.
But as Alexander the Great discovered that the more he expanded, the harder it was to manage, and that may be the case. That would be unfortunate. There could be a lot of value drift. depending on the different types of resources and the different sort of scenarios going on different corners of the universe.
Well, of course, I mean, the whole point of this scenario is to say there is a force that works against value drift that lets us predict. In a world where value drift is the main force, it's very hard to predict what happens because values could go everywhere, right? In a world where there's some sort of competitive pressure, like in this Cosmic Commons world or my Age of M world, then you can use that competitive analysis to predict what they'll do. Otherwise, it's just a vast space of possibilities.
Is there anything that we haven't covered, or is there any concluding statements you'd like to make?
I think we have roughly covered the basics here. The thing makes me, there is a paper if people want to look into more detail. I think I've given some talks where there's videos online as well and some slides out there. And they could look at the math and they could go farther. But, you know, it does mainly depend on this key assumption that you can't just go and grab everything all at once. Colonization will be this local process by which you land somewhere and then send out seeds to some other place and then keep going, because you can't just from one place send out seeds to the entire universe and be done with it. You know, I mean, that assumption might be wrong.
Yeah, solving global coordination problems is, I guess, a value that people with other theories about colonization behavior would share. So even if you're wrong or they're wrong, the project of solving these problems is still the same.
Everybody has always known that coordination and cooperation is an important issue, and the question is just when is it feasible or not? Like, people who want a world government don't disagree with other people about the value of coordination. They disagree about the feasibility of coordination. Some people think a world government would work well, and other people think that would be terrible because it would fall apart and be taken over by the wrong parties and things like that. It's not about whether coordination is good, it's about what social mechanisms we have available to us could achieve what kinds of coordination.
Okay. Is there any specific areas of research that you can point people at that you'd find high value in spending a lot of time and effort on?
So honestly, over the years, I have drifted away from this topic.
Sure.
Exactly because it doesn't seem pressing. I don't see any particular things we need to do now to deal with this problems later. The crucial point comes when this colonization wave starts, and we're a long way away from that. If you start out early colonizing and go slow, then the later colonization waves, they just pass you on, and you don't really have much impact. It's when people are able to move out at that maximum speed that the crucial point is. That's a long way away from now, so there are much more pressing concerns. So once I see the opportunity cost of my time, there are big issues now that we could deal with, like, say, the current pandemic. And I realize if I could devote my intellectual resources to figuring out how to do those things better, then there's a bigger payoff. Let the future work, figure itself out.
And we're becoming global pandemics tomorrow, so looking forward to that.
All right. Talk to you again tomorrow then.
Cheers. Thanks, Robin.
All right. Bye.